Hello aspirants, I hope all of you are doing perfectly well. So in today's lecture, we're going to be talking about the time evolution operator in quantum mechanics. So what is an operator that actually evolutes a state of a system from time t0 to some later time t? So we're going to see that thing now. Let's just name it the time evolution operator. The fact is we know that we know that if we know that the the transformation of psi of t0, that is nothing but the state vector of the state vector of the system at initial time t0 into psi of t, which is nothing but the state vector of the system, the state vector of the the state vector of the system at some arbitrary time t. Arbitrary time t is linear. Full stop. Therefore, there exists a linear operator. Therefore, there exists a linear operator u cap of t comma t0 such that it's a very important thing, you see, psi of t is actually equal to u of t comma t0 psi of t0. दैट इज अगर तुम्हारा इनिशियल स्टेट psi of t0 है तो उसके ऊपर ये ऑपरेट कराओ, तुम्हारा psi of t स्टेट आ जाएगा. Now we want to study the principal properties of this operator u of t comma t0. So this is equation number 1. Achha, just because the state psi of t0 is an arbitrary state, since get psi of t0 is arbitrary, therefore it's clear from 1 that I can very well write u of t0 comma t0. If the state is at t0 and you want to transform it into t0, should be equals to just an identity operator I cap. Very well done. equation number 2. It's a good thing. Now, putting this into the Schrodinger equation, into time dependent Schrodinger equation, now I can write putting 1 into time dependent Schrodinger equation, we get, what do we get? See, it's h cap psi of t, or rather I can write IH cut partial differentiation of t u of t comma t0. Hang on, rather I just want to write it as psi of t0. Let's just note psi of t can written as h cap psi of t, the most general form of time dependence Schrodinger equation, which can be written as IH cut partial differentiation of t. Psi of t can be written as u cap t comma t0 psi of t0 is equal to h cap u of t comma t0 psi of t0. Now, just because psi of t0 is arbitrary, so I can write IH cap partial differentiation of t u of t comma t0 is actually equals to h cap u cap of t comma t0. Right? So it's a very important thing. Now, just because psi of t0 is arbitrary, since psi of t0 is arbitrary, I can just very well write it since psi of t0 is arbitrary. Now I might tell you that this equation, suppose I'm just calling this, I'm just naming this equation as equation number 4. Okay, sorry, 1, 2, this can be taken as equation number 3. I can just simply mention that the first order differential equation 3 completely defines the first order differential equation 3 completely defines u of t0, u of tt0. The first order differential equation completely defines u of tt0. I mean, in a very natural way, together with the initial condition. Together with the which initial condition? This one. ये वाला initial condition होगा तुम ले लो कि u of t0 is equals to I cap. So together with the initial condition, completely defines u cap of t comma t0. Together with the initial condition that is equation 1. I'm sorry, not equation 1, equation 2. Right? This one was equation 2. Together with the initial condition 2, I can write. Rather इन दोनों को एक ही इंटीग्रल फॉर्म में भी तुम लिख सकते हो. Rather, rather, we can condense the equation 2 and 3 into a single integral equation. Rather, equation 2 and 3 can be condensed, can be condensed, condensed into a single integral equation. क्या है u cap of t comma t0, that is actually equals to I cap minus I by h cut इंटीग्रेशन t0 टू t, ये तुम देख सकते हो, जस्ट इंटीग्रेट कर दो, इसको इसको इंटीग्रेट कर दो, 1 बाई आई एच कट आएगा, बोथ साइड आई आई मल्टीप्लाई कर दोगे, इस एच कट को नीचे लेके आ जाओगे तो यहाँ पे एक माइनस साइन आ जाएगा, तो नेगेटिव आई एच कट दिस t0 टू t. Here you're going to get h of t dashed Hamiltonian operator, which can be taken as a function of t dashed operator, because you don't know the system is conservative or not. अगर conservative है तो Hamiltonian टाइम के ऊपर डिपेंड नहीं करेगा एक्सप्लिसिटली, अगर conservative नहीं है तो करेगा u cap of t dashed comma t0 dt dashed. ऐसे तुम लिख सकते हो, ठीक है, ऐसे तुम लिख सकते हो. Now, conservation of probability almost always requires that psi of t psi of t should be equals to 1, and that thing has to be satisfied. We know this. तो जैसे तुम conservation of probability करोगे तो तुम्हारा वो चीज तुम्हारा मान होना चाहिए कि the state of the system should be normalized at every instant of time. That's what I'm trying to say. तुम्हारा जो state है system का वो हमेशा normalized होना चाहिए. So just let me write it down for you. Just let me write it down for you. There is one more important thing. देखो, एक चीज है ऐसा कि अगर मान लो तुम स्टेट को इवॉल्व करा रहे हो, I can write psi of t psi of t is equal to u of t comma t1 t comma t0 psi of t0 psi of t0. Checking, I know, right? Again, मान लो, या rather अगर मैं इसको ऐसे लिखूं, psi of t comma t1 psi of t1 equal to this, and again psi of t2 I can always write as u cap of t2 comma t1 psi of t1 that can be written as that can be just put the value of this in place of psi of t1. You're gonna get u cap of t2 comma t1 u cap of t1 comma t0 psi of t0, and therefore I have another thing to write. Just assume this thing that this thing can also be written as u of t2 comma t0, these two things psi of t0. Therefore, altogether I must write u cap of t2 comma t0 can be written as u cap of t2 comma t1 u cap of t1 comma t0, that thing. Assuming t2 is greater than t1, that is greater than t naught. Let's say this, that we can do. So what can you write if I just you know if I just so I know this formula is true. So if this formula is true, so let's now put these two things, t2 equals to t naught. If I do that, so u cap of t naught should be t naught t1 t1 t0. Now let's put t2 equals to t naught. So what this will provide you, u cap of t naught should be u cap of t naught t1 into t1 t0. I can write it t naught t1 and t1 t0. I know this. But this one is actually your I cap. This one is actually your I cap. So I cap is actually equal to your u cap of t naught t1 t1 t0. I know this. Now I have to prove that okay, I know this equation, right? If I know this equation, in the similar manner, I can also prove it like t1 t0 t0 t1 is also equals to 1. If I take t2 equals to t1, suppose, so t1 t0 t1 t1, okay. T1 t0, good. So I can do one thing, I can interchange another thing. from just taking this equation into account, can I write down another equation which says like um, we just know this thing, right? So from this equation, similarly, can we write another one? Say u cap of T2, T1. Can I just write it down as like u cap of, I'm just getting, first of all, T2, T0, then I'm doing T0 to T1. Can I write it like this? From T1 I have got to T0, from T0 I got to T2, that means from T2 I have got to T1. I've done this thing. If I can do this, then putting T2 equals to T1 I can write then putting T2 equals to T1, I can get I cap is equals to U cap of T1 T0 to U cap of T0 T1. That's all. And if this thing is done, therefore from these two equations I can write, therefore U cap of T1 comma T is actually equals to U inverse of T comma T1. That's one thing. That's one thing. Now, let's calculate the evolution operator between two instants separated by. Let's calculate the evolution operator between two instants separated by dt. So what can you write? You can simply mention d psi of t is equal to psi of t plus dt minus psi of t minus psi of t, that is actually equals to negative of I by h cut h of t psi of t dt. That's coming from the Schrodinger equation. Of course, no doubt that's coming from the Schrodinger equation. And therefore, psi of t plus dt is, can be written as I cap minus I by h cut h cap of t dt into psi of t. This thing you can write. So therefore, u cap of t plus dt to t. T से t plus dt जाने के लिए जो operator, that is actually your I cap minus I by h cut h cap of t dt, that I can write. It's an infinite symbol operator, right? Of course, it is unitary. And from this equation, you can just actually find out the time evolution for an infinite period of time. In case of conservative system, we know the Hamiltonian does not depend explicitly on time, and then you can integrate it. You can simply integrate. And by integrating, you can just write it down. In case of conservative system, partial differentiation of h with respect to t equal to 0, that means Hamiltonian does not even explicitly on time. Then this equation 3 can be integrated, taking initial condition as equation 2. Equation 3, I will just turn off this so that you can see the entire screen. Equation 3 can be integrated taking initial condition equation 2 and we get u of tt0, u cap of t comma t0 is actually equal to e to the power of negative of I h cap t comma t0 by h cap. So this is the time evolution operator. It's a very important thing. This is how you write it down. This is your time evolution operator. This is your time evolution operator then. So I hope this was helpful and thank you very much. Mostly हम लोग क्वांटम मैकेनिक्स में कंजर्वेटिव सिस्टम के साथ डील करते हैं. तुम लोगों की क्लास में तो कंजर्वेटिव सिस्टम को लेकर तुम लोग डील करते हो हर जगह जहाँ पे हैमिल्टोनियन टाइम के साथ एक्सप्रेसली डिपेंड नहीं करता है. तो उस केस में तुम्हारा ये चीजें ऐसा हो जाता है. U cap of t comma t0 becomes equal to this. बट अगर सिस्टम कंजर्वेटिव ना हो तो वो अलग हो जाएगा. वो ऐसा नहीं है. ठीक है. चलो, थैंक यू वेरी मच. वी विल अगेन मीट ऑन द नेक्स्ट क्लास. थैंक यू.